Hello and welcome. In this video, we are going to solve problem number 24 of Leetcode, that is swap nodes in pair. So we have given a linked list and we have to swap every two adjacent nodes and return its head. Okay, you must solve this problem without modifying the value in the list node. So we can't do just swap the values of this adjacent node. Like we can do one thing, like we can swap this value of 1 with 2 and 3 with 4. So this is not allowed in this problem. Okay, so what we have to do, we have to swap the linked list nodes, not the value. So how we can do that? So we have to we have to swap this adjacent nodes, like 1 will be swapped to 2 and 2 will be swapped to 1. Similarly 3 will be swapped to 4 and 4 will be swapped to 2. So this is going to be our result, that is 2 1 4 3. Okay, so there can be many ways to solve this problem. The one way is the iterative way and the another is recursive, that we are going to talk in this particular video. So first we'll be discussing the iterative solution and then we'll code that, then we'll come back and discuss the recursive solution and then again we'll code that. Okay, so how we can solve this problem using iteration. So we have first what we want to do, that we want that our 2 should be at beginning and 2 should be pointing to 1. Okay, so this is what we want. 2 should be at beginning and 2 should be pointed to 1 and 1 should be pointing to 3. So for that we will be taking a help of a dummy node. Okay, so this is our dummy node that we will be creating. So let's create our dummy node. So this is a dummy node and we will be taking these two nodes. So we can name it node 1 and node 2, but we'll make something that can be more declarative. Okay, so we'll be using this here pre, and this is going to our current. So this is two node that we are creating and we will be working on this. So first what we want that this dummy should point to this 2. Okay, and then we want that 2 should be pointing to 1. So the first step is we'll be simultaneously we'll be writing the pseudocode for same. So we'll be running a while loop until unless we'll reach the till last index. So we'll be checking that list, that is our current node has not reached, current is not equal to null and current dot next is not equal to null. Till then we will be running our while loop. Okay, and then first what do we want, that our pre should be pointing to this, should be pointing to 2. So this is the first that we want. So for that we'll be doing pre dot next equal to, how we can reach at index node 2, we can reach it using current dot next. Current dot next is going to our pre dot next. So first step is done, so we will be making a connection between these two. So this has been done. Okay, then what we want that this 2 should be pointing to 1. So we can't directly make a link between these two. If we'll do that, then this is going to create a cycle and we'll never getting out of this cycle. So for that first we have to pointing this 1 to somewhere and then we can now make this 2 to 1 node, 2 to 1 connection. Okay, so for now I am removing this connection. Okay, so where we can point this 1 to, so like we can say that 1 should be pointing to 3. So for that we will be doing 1 should be pointing to 3. How we can point 1 to 3, we can do with using cur dot next equal to pre dot next is 2 and we will by that we will be able to pre dot next we will be able to point come to 2 and then we will be pointing to next of 2, that is pre dot next, that is 2, and then their next is 3. So we'll be pointing current dot next equal to pre dot next to next, that is 1 will be pointing to 3. So this has been done. Now we can point, as this connection has been established, we can remove this one. Will this connection will be removed by itself. Okay, so now it's time we can point 2 to 1. So we can point this here. Okay, so for that what we have to do, we have to do pre dot next, that is 2, and after that next, that means 2 next is going to be our current. Okay, so this connection has been established. That until now what we have done, we have created a pre, and pre is pointing to 2, 2 is pointing to 1, and 1 is pointing to 3. Now 2 is pointing, 2 is also pointing to 3. So this sorry, 2 is not pointing to 3. Whenever we will be pointing to 1, this node will be removed, this connection will be removed. So we forgot to remove that, so this will be removed. Okay, and this is what we have done yet. So 1 is pointing to 3 and 4. Okay, for the next term we have to update our pre. Our pre will be going to, till now where we have solved pre to 1, so we will be updating our pre, that is pre is going to our current value, so this is going to our next pre. So this will be removed, this will be removed, this is our pre, and till now cur is also this, so pre is going to our cur, and we have to update our cur also. Cur is going to cur dot next, that is 3, this is 3 is going to our next cur, so this is going to our next cur, so cur is going to cur equal to cur dot next. Okay, same will be followed for next iteration, and if you want to check you can do by self. I'm not going to do that because it's going to get our video too much lengthy. Okay, so same step will be followed, and at last we will be able to make our list. So let's go to the compiler and write the code for same. So first we'll be checking if our head equals to null or head dot next is equal to null. In that case what we have to do, we have to return head itself. We don't have to do any work. Okay, now we'll be creating a dummy node, and then we have to create two nodes that we had already discussed. List node pre equal to dummy and cur equal to head. Okay, we'll be running a while loop till cur is not equal to null and cur dot next is not equal to null. Okay, now first we have to make pre dot next equal to cur dot next, and then we will be making cur dot next equal to pre dot next. Okay, then after that we will be making pre dot next equal to cur. Okay, and then we have to update our pre and cur. Pre is going to our cur, and cur is, will be updated using cur dot next, and at last we have to return our result, return dummy dot next. As we can't return dummy is our initial node, we have to return next of that. Okay, now run this. So we have passed the first test case, check the remaining two. It's time to submit our solution. So yeah, our solution has been accepted, and it is 100% faster than online Java submission. Okay, so we have done with our iteration path, iteration way. Now we will be checking the recursive way. So let's go to the compiler, let's go to the board again, and first understand the recursive way. So we will be creating the same 1 2 3 4. Okay, so this is our list node that we have already given. Okay, we have to solve this problem using recursion. So what we want, so first we want that 2 should be pointing to 1 and 1 should be pointing to 3 and then 4. Then in next step we will be swapping these to 4 and 3. So at first what do we want, we want this to be done. So we will be focusing only the first part, and rest will be solved using recursion itself. So this can be in long also, 5 6 7 8 n number of. So rest will be taken care using recursion. So we first we only have to take care of this part. Okay, so again what we want, 2 should be pointing to 1. So we will be going to take help of recursion for that. First we will be checking if our base condition, if our head equal to null or head dot next equal to null, then we will be returning our head. So I'm not writing this that base condition. So we will going to need a new node, that new head that we have to create. So our we have to change our head. So how we can do that? So new head is going to, this is our head, head dot next. We want to that 2 should be our new head. So for that we will be doing, this is our head for now, okay. And we want that head dot next should be our new node. So head dot next will equal to new node, the first step, okay. And then what do we want? We want that new head dot next should be, this 2 should be pointing to 1, okay. Before that, if we will doing that, we have to preserve the next node. So for that we will be storing list node. Like if we will be pointing this to 1, then this link will be deleted, and then we will not able to traverse rest of the list node. So for that we have to store the these three nodes somewhere. So we'll be using that, we'll be doing that using temp will be storing head dot next and next, that is here temp has been stored, okay. Now we want that two should be pointing to 1. We can do that using new node dot next equal to our head. So this will be created and this will be removed. So let's remove this, and this is, this has been created. So first, and this will also be removed, okay. For now this node has been created. So come back, and list node dot next is going to our head, okay. And we want that one should be pointing to reverse part of this remaining nodes. So for that we will be calling our head dot next equal to, let's say recursion is going to solve all the remaining parts. So for that we will be calling recursion from here swap function, and we will send our temp, okay. So this is going to something like 4 3, this is going to something like 4 3 6 5 8 7, that is going to return by recursion. So we are pointing this one to this node, okay. So that we are doing head dot next equal to swap dot next. So for after that this node will be deleted. Now if we'll see, then 2 is pointing to 1, and 1 is pointing to 4, 4 is pointing to 3 and 6, and then 5, similarly 8 and 7, okay. So we have only solved this part, and rest will be solved using recursion, okay. And then at last we have to return this new head that we had created, okay, new head, okay. So this is the pseudocode that we have to follow and write the code for same. So let's go to the compiler again, and first reset this solution. Actually we don't have to reset all, okay. And then we'll be checking if our head is null and our head dot next is null. Then in that case we don't have to do anything, just return the head. So we'll be getting new head first of all, which is going to new list node, okay. And then list node, we will be storing the temp, the next node in the temp. So this is going to temp equal to, actually new node is going to our head dot next, yeah. So temp will be stored head dot next of next, and then new node dot next will be updated, that is our head. And we have to update head dot next. Head dot next is going to our solved part using recursion swap pairs will be called, and we have to send this temp here, okay. And at last we will be returning our new head. Now run this. Sorry if there is a problem that we forgot, okay. Now run again. Sorry, yeah, okay. So all the given three test cases has been passed. Submit this. So our solution has been accepted, and this is also faster than 100% of the Java submission, okay. So in this case, if you learned something from this video, please make sure to like the video, subscribe to our channel, and don't forget to share this video among your friends. Thank you.